Hi guys, I'm back. So this was gonna be that video in which we were gonna demonstrate this Kromrey, and well, as you can see, I finished the course, and I sort of already did some tests with wire on it, and well, I figured out that the magnet stack on one side was oriented in the wrong direction, so we had no cogging in first place, but once I resolved that, there was a lot more cogging. And also, when spinning it up, we can see, well, this LED would generate some light at a certain speed, but it would slow down the generator once shorted. So this is not what I was intending to build. And we'd also discuss that when placing these magnets more outward like this, wait, like that, so we could probably tune the circuit and, well, get less cogging or slowing down from the generator. This was not the case. I figured out that even when putting the coils all the way down to here and spinning it up, it would still slow down. So what I think is what we're experiencing here is too much interference from these magnets. Actually, these magnets are quite strong, so I think they're just not the way to go. What I also noticed is that when the magnet stack is oriented in the right direction, well, then you don't have this cool breeze. Like, you do still feel the airflow from, well, it being certainly like a fan, but it's not that same cool. So right now it's in the bucking mode again, because I did some experiments with it as well. And I rewound one of the coils so that we could try and see if there was some power to generate from it. Nothing would actually generate, the LED would not come on, but the cooling effect would be there again. So something with bucking magnets and cooling apparently. But I was not gonna build a fridge, so so I guess we'll leave it, for what it is. What about this little thing? Didn't we say we had some success when the iron poles were still longer? Well, yeah, there was some success. It's kind of hard to explain how that would have worked, while on the bigger one it does not. So here's the idea. I thought, let's go read up more stuff about Kromrey, and what better way to start than to read the Sajeka file. So the other day I figured out that my Sajeka files disk didn't work anymore, so I sent a message to the, well, energy from the vacuum people when they were still around, and they sent me a new one. So here it is. Oh, wait. How did this thing break? I mean, it was just on the stack, right? Like in between somewhere like this. And all of these discs are okay, but this one is not. Like, how did that happen? Look, here's the old one, and well, it's still a CD that you can put in a drive, so kind of fun to check it out. So here is that DVD, and let's check out. I thought it was around 60 or so. Wait, here, 66 Kromrey generator. And then it opens. Like, yeah, you can no longer, or has expired, can no longer be displayed. Yeah. If you're kind of handy with computers, you probably know what to do now. There we go. So I'm just starting up my XP because it's much better than the newer Windows, obviously. Don't you love the sound? Right, you can see I already copied some into the desktop here. And well, let's go and make this stuff work. How did this work again? Right, here we go. Not automatic. Put it to 2012 or so. 12. Apply. Let's see. 66. Right. So here's that. Well, apparently it's the patent. So it's just a patent, and then yeah, some other stuff like desktop toy. Not really important for what we want to know. So I'm guessing we can close XP again, and basically the patent is found online as well. So if you're curious, it's just found on well, Google patents or so, and under this patent number 3374376, it has a better image, so image quality is better. It's just all in all better, and the text is not modified, so I checked actually. So if you want to know, it's right here. And while reading through this stuff, not much new that I found apart from this right here. Kind of tells what needs to happen. Also, what I found out is that yeah, you can use magnets, like permanent magnets. They say that in this patent, but usually what happens and what you see in the images is that there are coils. Well, here's one with the permanent magnet. However, this permanent magnet ain't no ferrite. No, it's an iron kind of like magnet, a soft iron magnet, in fact. Well, these things ain't salt, so yeah. I don't know where the idea came from to use the, well, ferrite magnets. I'm guessing it's the image or like video John Bedini shows. But then again, he uses the barium ferrite magnets, and these have total different properties from the, well, the current ferrite magnets. So if we want to kind of succeed, we should probably stay away from these ferrites. What are you saying? These iron magnets, I know them. I've seen them before. It's like the U-shaped or the horseshoe magnets. Well, no, those are alnico magnets, so they are not the soft iron magnets. Well, that's what I thought, but it isn't. And so, how are barium ferrite magnets any way different than strontium ferrite magnets? I mean, they look the same, right? But if you go and research some more and go into detail, you'll find out that barium ferrite magnets are actually have different properties, like they are able to be made into an electret, which, well, might not be necessary for this purpose right now, but it's possible, and strontium ferrites definitely cannot have that. Also, barium ferrite magnets, they can hold a lot more magnetism than they're usually magnetized to. Hence the reason that they can be, well, sort of inverted, like persuaded to change polarity, right? And strontium ferrites don't have this property. So I looked around, and there was one company which, well, kind of said they sold barium ferrites, and they checked back and they didn't have this magnets anymore. And also the supplier of them, they also didn't sell the magnets, so I'm guessing they're gone. Well, there's one other way to make this Kromrey without the need for those specific magnets, which is soft iron. And we have a bunch of welding rods here, which are exactly the soft iron. The only thing is they are not magnets, so we kind of need to wrap some coil around it and well, magnetize it, and that way we can still make it. Well, it looks like you're still hanging around to know more. Let's figure out why this Kromrey generator should work. and how it works. So at first I was searching and finding out the way magnets are actually working, and I found out that there are two ways to make a magnetic field. The first is to have a current in a conductor actually makes a magnetic field. As you know, electromagnets, that's how they work. But also another way to have or make a magnetic field is to align electrons, like their spin, that is. So aligning electron spin is what happens inside the iron. So if you have a current in a conductor generating a magnetic field, the iron sort of aligns. I mean, their electron spins align so that there will be a second magnetic field adding up to it. This is kind of important to know because once the conductor is, the power is turned off from the electromagnet, the electron spin alignment will also scatter again. So that way we lose the magnetic field. But, and there's a but here, I don't know if you know Athlete Skalnin's perpetual motion holder, which is basically a U-shaped electromagnet and then a piece of iron to connect the, magnetic flux path together. Well, this perpetual motion holder definitely shows that the electron spin alignment can be maintained if the magnetic flux path is closed in a closed loop. And the same is what we're doing in the Kromrey generator. We're trying to close the flux path and that way maintain the electron spin alignment. So let's have a look at a drawing to see what that actually looks like. Here's a coil, and basically we put power on it, we get a magnetic field, right? We know it looks something like this. So on the right here we have a block of iron, and basically on a super small scale we have these electrons all over the place, and what naturally happens is that their spin is not aligned. So wait, let's focus in there. So this one goes this way, and this one spins that way, and maybe this one spins this way, and another will spin this way, right? So they're not aligned, and so no magnetic field is generated. So here we have that same iron bar with the electrons inside, and once we manage to align the spins, we can see a magnetic field emanate from the iron bar. So here's that perpetual motion holder I was talking about. It's basically a U-shaped electromagnet and then a piece of iron stuck to it. Basically, the way it works is normally this iron piece doesn't stick to the other piece of iron right here, but once we magnetize the coil and the electron spins align, then it will grab onto the other piece of iron. When the coil is de-energized, it will keep connected to each other because of the spin alignment. And what's interesting about that is that when you break the flux path by mechanical force, you can generate power afterwards. So I've seen a video that had this perpetual motion holder connected for like 2 years, maybe more, and then the guy pulled the perpetual motion holder apart, and it would light his LED still after 2 years. Obviously, for a Kromrey generator, we're not gonna wait 2 years for the next cycle. We just want to generate every cycle, so like every rotation, but the principle remains the same. So I went looking around, and there's this image I remember from, probably some website, and I can't seem to find it anymore. But then, this book sort of shows a page in which he kind of refers to the principle I'm trying to talk about. Let me find it. Here you can see what basically needs to happen is a two-phase system in which one, the motor turns on, and secondly, the generator generates. Here it says 2 motor and 2 battery. So the two-phase system first turns on the motor in order to rotate the contraption, and then the two battery is obviously the generator phase. In this case, the motor is also the exciter of the iron pieces in the magnetic circuit, so that the generator can actually generate. As for progressing with this build, I will probably progress with this build. However, I don't think I can sort of post everything. Like, it was already hard enough to like step over this, you know, to say something about it. So this is it. This is the Kromrey and what I found out about it. Other than that, I also have my other hobby, which is playing around with C++ on the computer. Let's have a look. Remember last time, or like in the video I posted, you could see like this Ferris wheel I printed, and well, it has an ESP32 and it communicates to the computer, remember? And also it has a wireless electricity module to transfer the electricity from one side to the other, to be completely wireless in power supply and communication. Well, I sort of stripped the Ferris wheel code from the software and, well, made it into a library you can use for other projects. So it's very easy to set up a communication with the ESP32 and set up like a OPCUA server which automatically adapts and to your code. So with the OPCUA, it's basically an industrial protocol in order to have tags, basically variables, and well, structures like folders and such available for you to well, modify and work with. Basically, to make a human machine interface like HMI, you can use the OPCUA for it. And so you can control your ESP32 or multiple of them with the HMI. It's kind of interesting. So here you can find my GitHub. It's GitHub Synchronous Maximus, and you can find the code at tcom tests. And the software you download to the ESP32 is here in tcom ESP test, and a computer program which you can run on your well, computer, laptop, or whatever is right here. It's a tcom win terminal, so like it's a terminal program. You can as it says, compile it with the platform.io for the ESP32 and MinGW64 compiler for the Windows build, and have a lot of fun with it. I know that was a lot to take in, so feel free to watch again or so. But for now, that's it. And thank you for watching, and I hope to see you next time.